All right. Now for covalent compounds, we're sharing electrons. So let's say we put together oxygen and chlorine. Okay? Let's put together oxygen and chlorine. So how many electron dots? So we don't even have to worry about the orbital notation for this. It gets too complex to try and use overlapping orbitals in orbital notation to show this. Yes?
6 for oxygen.
6 for oxygen. 1. Okay. Now Marty had that right off the top of his head. Okay, maybe you don't. If you don't, and you don't understand how we got that, you need to let me know now. Huh? Oh, good question. Thank you for asking. All right. So oxygen's valence level is 2. It's the second primary level. It's in the second primary level on the periodic table, or the second row. So it has a valence level of 2. Okay? In the second primary level, then for oxygen, we have these 2 s electrons here, and the 1, 2, 3, 4 electrons represented by these elements. That's a total of 6 valence electrons. That's where we got the 6 from. I put 7 on there. It should be 6. Okay? So oxygen should have 6 valence electrons, not 7. All right? So how many should chlorine have then? Using that same system, 7. How many should chlorine have? So you should have a periodic table out. You're supposed to keep it out. Just get it out of your notebook. Have it out. There you go. 1, 2, 3, 4. 1 on each of the 4 sides, and then you can pair them up until you get to 7. Okay. So what we want to do then is to get. We will need another chlorine, but let's go through the whole system here for a second. What we're going to do is share electrons, and we use what we call the sharing arrangement here by starting out by circling these. So before I did any circling, those were just the electron dot formulas. When I started circling, I'm doing a sharing arrangement. Okay? So now I'm putting together a sharing arrangement.
Like when you do the circling, the sharing arrangement, when you do the arrows, what, giving it off?
Yeah, well, I don't have a name for this. It's just giving up, showing where the electrons are going. Okay? All right, so then that gives chlorine 1, 2, 3, 4, 5, 6, 7, 8 electrons. Because we're sharing this electron here, it gives chlorine 8 electrons for the valence level. That's what it wants to have, okay, to be more stable. Oxygen, though, right now has 1, 2, 3, 4, 5, 6, 7, and it needs another one to be as stable as it can be, okay? So we need another chlorine to make that happen. Put 7 dots around chlorine and share these 2 electrons right here. Now this oxygen has 8. 1, 2, 3, 4, 5, 6, 7, 8. And this chlorine has 8. 1, 2, 3, 4, 5, 6, 7, 8. And that makes all of the elements in this compound more stable. So that's the sharing arrangement. To get to the Lewis dot formula, we're just going to squeeze those electrons in between the atomic symbols. So between oxygen and chlorine, we're going to squeeze these 2 electrons in there, like this. All right? Between this oxygen and this chlorine, we're going to squeeze those 2 electrons in between, and it looks like this. But we still have to go back and put all the unshared electrons around there. So those are the other unshared electrons for oxygen. There's the unshared electrons for that chlorine and the unshared electrons for this chlorine. Okay? So this then is the Lewis dot formula. Okay? Then the next step is to find the Lewis formula. And in the Lewis formula, we replace shared pairs and only shared pairs with lines. So oxygen gets written here. There's one shared pair between this oxygen and chlorine, so it gets 1 line. And one shared pair between this oxygen and chlorine, so it'll get 1 line. But we still have to show the unshared pairs, also called lone pairs. Sign in and put this in your personal file. personal folder. Okay, so those are the Lewis formulas. Okay? That's pretty much kind of a headline version of all the Lewis formula stuff to review. Any questions about that?